Hello, space fans. This is Greg Allison with Galactic Greg's coming to you with a big question. Will asteroid 2024 GJ2 impact the Earth? Well, I'm going to submit it's going to be a cliche, but probably not. Not very likely. In fact, asteroid 2024 GJ2, that's a mouthful for me and you, right? It is projected to pass Earth with a distance of 11,600 miles. It is the size of a car, roughly about 3 meters or 9.6 feet. And it's bucking along fairly fast, but at that size, unless it's an iron meteoroid, it should hit the Earth's atmosphere. It should break up in the upper atmosphere. Now, if it's an iron meteoroid, it might get, it would get through. But and then again, even if it were a more dense meteorite or have iron components, some of that stuff might get through. But this is not a ginormous asteroid. By comparison, the Chelyabinsk asteroid which caused some big problems over Russia, was about 18 meters in diameter. That's considered about the threshold, the criteria of something that can do damage on the ground, because even though that one exploded in the air, it did knock out a lot of windows near Chelyabinsk, Russia, and cause some damage. In fact, I think there were some injuries from broken glass from people looking to see what that bright flash was in the sky. Sometimes looking for the bright flash when you're looking through windows can be a problem, whether it's a meteoroid or something else. So I'm going to share some screens. Now, I can't say that it won't hit Earth, but it's not very, very likely because it looks like it's going to just graze by. We'll go into that. I'm going to open up the chat room here. Give me a second to see who's here, because this is not breaking news. I didn't want to just record a video and put it up because that would take an hour or two. I wanted to get it out here at this news as quick as I could, so that people could at least digest this, because I've been getting some messages about this asteroid. Some people were concerned about the impact or potential impact of it. That's why I'm on here. That is why we're here tonight, guys. So just to bring everybody up on this, we're going to go to the screen share and look at some of the data on this. Now, if you go to spaceweather.com for this asteroid, we looked at this last night on my Silverhead News channel, and this wasn't here. This wasn't on the charts. I said, hey, there's no known asteroids that's coming in between the Earth and the Moon. Well, there are now. As you can see, it was discovered this year, and by the late letter G, it's a recent, very recent discovery, as is this one here too. So, and it's projecting 0 lunar distance. Now that looks like an impact, and that's enough to get a lot of people concerned when you go into space weather and you see the missed distance is 0. Well, it could be, but let's have a look-see. Let's look at it, because this is what's actually projected right here. It's projected to miss us by 0.05 lunar distance. Remember, this chart back here is in lunar distance. Maybe they just can't go, well, they do have decimal points in there. Why they put 0? Maybe these guys are expecting an impact. If it does, it's not something to be frightened over. That's the good news. So if you look at it, this kind of depicts what they think it's going to do. And this outer circle, I believe, is the diameter of a geosynchronous satellites. Most likely, that's what that's depicting. So what you see, it looks like the orbit will be bent, just coming through Earth's gravitational field, because that's not a straight line. When something passes close to a gravitational body, it bends the orbit. So you can see Earth has a diameter of 8,000 miles. And this is about the missed distance. Now, you're looking at an angle here. That's why it looks like it's coming in closer here, but I think that's actually supposed to be the missed distance. So, like I said, Earth has a diameter of 8,000 miles, and so it's going to miss us by more than the diameter of our planet, or so we hope. But even if it don't, threat should be a nope. So this asteroid was first observed by the Pan-STARRS 2 actually on the 9th of April. So I'm surprised it didn't make the list that we looked at last night on space weather. They just put it on there. So here it is, guys. To show some bend here, as I mentioned earlier. This is a look at the overall orbit from, you can see it goes out farther than Mars, the planet Mars. This is called an Apollo asteroid because it does come within the orbit of the Earth, but it's, most of the time it's in further out in the solar system. This one actually comes close to Venus, though, at some point. So what we're going to look at here is a bunch of other similar objects. So we're going to go back to space weather because we've got a little bit more things we can do over here, because we can click on the asteroid itself. And this takes us to the Jet Propulsion Laboratory's small body database lookup, which is a very handy resource. It can talk a lot about this thing and tell you a lot of data about it, orbital periods and all that kind of stuff. You probably don't want to get all in that. But the cool thing in here is that we can actually look at the orbital viewer. And we can speed it up. We can slow it down. Earth is in blue, Earth's orbit. And this would be, this little dot here would be Earth. Looks like that's probably on the dot. The dots are probably coincident there because it's so close right now. So if we play it forward, the dots are right on top of each other. Look at that. See, right now it shows it being the dot for the asteroid and the dot for Earth are just right on top of each other. But we're looking for millions and millions of miles out in space. When you're looking at something that's 9.6 feet across, the resolution gets a little low this far out. Now you can see it pulling away, but that's the way it shows it right now. And we can turn this thing around, look at it from different angles. That's what's cool about this viewer here. It gives you a lot of parameters to play with. We can even make it full screen. Bada bing, bada bang. That might have been a mistake. If I can get out of that. There we go. So what are the choices we got here? So that's what we're looking at from that angle. But let's go on and talk about a little bit more over here. This is from the Jet Propulsion Laboratory's Asteroid Watch page. And what they've got is next 5 asteroid approaches. Now this was it's 12:07 right now, so this would have been yesterday's. The one that was 100 feet in diameter, so you can click on feet or meters, either way, for our metric-oriented friends. And we can see that one missed us by a good long distance, almost 3 million miles, 2.8 million miles. This guy, though, is coming in, like I said, at 11,600 miles, closest approach to Earth. 11 April. Wow, it's my dad's birthday. I wish he were still with us. He'd be 103 today if my dad was still alive. Anyway, so it's a car size, roughly 9.4 feet or 2.9 meters. It was listed as 3 meters. When you really drill down, it's 2.9 meters is what they believe. Let's see, what does this take us to here? Oh, yeah, the same asteroid small body database lookup what we were at earlier. So there, my friends. That tells you a lot about it. So let's go a bit more detailed in the asteroid impacts in general. So when you're looking at asteroid impacts in general, what they look at here is the evaluation of this parameter. This is for possible impact conditions. They do evaluations for this parameter for a minimum asteroid size to cause fatalities, 18 meters. So anything under 18 meters, they're not expecting fatalities from. And for a surface impact, the asteroid's usual size is 56 meters. So an asteroid needs to be about 56 meters to actually hit on the surface of the Earth. But as we know, the Chelyabinsk asteroid was about 18 meters, didn't hit the surface of the Earth, and it caused injuries due to broken glass and overpressure of the explosion. We also know that the Tunguska asteroid, which was much larger, flattened trees over an area about the size of Washington, D.C.'s, inside the Beltway there that goes around Washington, D.C. So that would have taken out a large area, could have done extensive damage if it were something the size of the Tunguska event, which occurred in 1908, just over 100 years ago. So this is a asteroid size and probabilities chart here. This is a much bigger presentation, but for what you want to see, it talks about the likelihood of asteroids across various sizes. You know, this is getting out toward Apophis range down here, and they're huge but unlikely to hit. According to this, the most likely range to hit is in this area here, and this is a diameter in meters. So this, of course, they're looking for what can cause damage. Any of these in these bars could cause damage. Now, this lower bar is within the threshold of what would blow up in the upper atmosphere. That's why, and even this one, this is why they're lower on the scale here of probability causing damage on the surface of the Earth and other things, and probability overall of hitting. So upper size range can be large, but relatively unlikely. Smaller size ranges are generally more likely. Asteroid properties, density, composition, structure, strength are usually unknown. So, that has a lot to do with what comes through. It says they range from stony types of asteroids. This is ones that are most likely, or carbonaceous asteroids, which are more volatile carbon type materials, most likely to burn up in the upper atmosphere or shatter. Rubble piles, which are likely to come apart. Big asteroids like Bennu, we see as a big rubble pile. Or your rarer iron type. Fortunately, those are rare, but those are also high density and could make it through. Maybe even smaller ones, if they're iron, would come through. We don't know what this guy is yet. We just discovered it on the 9th of April. It just got posted on Space Weather probably today. It was our last live session. It wasn't there. So you can, this is a little data sheet on this asteroid. And it don't, you got to dig in here to really get the details in this sheet here. Doing so, I went into it here and looked at possible impacts. I clicked on the possible impacts for this asteroid, and they show it in 2035, 2041, 2043, and 2062. So there are years out there that it may have a higher possibility of impact with Earth than today. But if it does hit today, it shouldn't scare you, because most likely this one isn't going to do anything other than explode in the upper atmosphere, I guess, unless it's iron. And if it does, 2/3 of the world's surface is water. And this one is not big enough to cause a tsunami that would be appreciable anywhere. Now, if it wouldn't cause a tsunami. So if one like this were to hit on land or somewhere like that, you got to remember, most land is also desert, tundra, things like that. Most land even don't have cities. We're here in America, we're like the ant that's always on the ant trails or in the ant colonies. We think the whole world's covered with ants or people. But when you fly over the plane, you'll discover that ain't exactly so. Now, there is an asteroid that this website here, sci-fi.com, thought could strike Earth later this year. They call it a lost asteroid 2007 FT3, but I don't find any data to support that on this asteroid either. I looked it up, and it don't have an near past Earth for some time, and it looks like all misses. I did do some search on this asteroid here, because here is when it's supposed to be making its next approaches. It came by in 2007. It don't come by again to 2067. So where did it get this year impact? I don't know. 2181 is another year. And I think Bennu has got a chance of hitting Earth in 2181. That would be, although it's remote chance, that would be a very bad day if Bennu hit Earth. Bennu is huge. That's the one we just brought the sample back from. It does have an existent probability that it might impact Earth, albeit small. At least that's what they think at the time being. Let's hope it stays that way. This is going to be a short video. I just did this one live because I wanted to come on here quick and give you guys this data. I did not want to go through and wait till I got to upload it and all that kind of stuff. I was just trying to get the most audience I can get, just so I can get the word out, because I was getting a lot of messages about this. Now, this is a chart of size of asteroids versus the probability when they might hit us. This year is the impact. This angle, this axis here, is the impact interval, how many years it takes for an asteroid on average of these sizes to hit Earth. This is a logarithmic scale. So this is 10. This would be 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. That means this is 10 years. This is 100 years. This would be, well, no, excuse me. That'd be 1 year. This would be 10 years. 100 years is 10 to 2. Anyway, so that's how this goes down through here. Million years, 10 million years. So if you look down, Chicxulub is past the 10 million year mark. That's, it hit us 65 million years ago, supposedly. This is what is believed to have taken out the dinosaurs. Major impact. This thing, if you look on the size range of it, it was, that ain't size, diameter is down here. 10 kilometers in diameter is what they believe that was, or 6 miles for the Chicxulub asteroid. Tunguska asteroid was, much smaller. I'll have to look up the size of that one again. The Chelyabinsk asteroid again was about 18 meters right here. And I said that's a fairly frequent, maybe every 10 years or so kind of a impactor. So this thing is, I like the way you're doing your channel, brother. Hey, thank you there. So the good news, hey, Bev, the good news is that this asteroid that some people are worried about is just not likely to hit us. We'll come over here and look at this, the Chelyabinsk meteor. Let's pull this up. We can see it making a bolide across the atmosphere in Russia. That was quite a boom right there. It took out a lot of windows. I think it actually did a little structural damage. I think there were a few bricks and such knocked loose, but mainly windows. And a lot of people got cut from shards of glass. There were a lot of windows destroyed when that one came through. Super bolide. It was, again, 18 meters in diameter is what they believe. There were actually pieces of that when they hit the ground, but nobody was hit by the pieces of it. So, yeah, let's see, this would be the Tunguska, I believe here. This is a Chelyabinsk, Tunguska. Compare the Eiffel Tower and Empire State Building. So if you want to look at Tunguska event, like I said, the Tunguska event knocked trees down for an area that was roughly equivalent to the size and the area of Washington, D.C. It hit in Siberia. Just look through the pictures here. They went to this place in 1930, years after it impacted. So I think it was about 65 meters. The Chelyabinsk meteor was 18, 20 meters. Just gives you a comparison of the sizes. So rock this size, which would almost fit underneath the arch of the under the Eiffel Tower, caused a lot of damage. So this is the size of the meteor that caused a Barringer crater, which is that big meteor crater in Arizona. That's a huge one. Chelyabinsk meteor was like this. The Tunguska meteoroid was somewhere from a little bit bigger than the one that caused the Barringer crater, maybe a little bit bigger. It was somewhere in this size range. That was the meteoroid size. This is the size, again, of the Barringer crater making meteor. No, the crater is much larger than that compared to Boeing 747. The Chelyabinsk, this is some other meteor from 2009. I'm not familiar with that one. So just kind of walk back through the pictures here. That's the angle that they believe they come in on, where Tunguska is. So that just gives you some comparisons of meteors to put this one in comparison to things that have done damage on the ground at some of the lower size thresholds. Like I said, they think that needs to be about 54 meters diameter to actually hit the ground. Tunguska meteor actually didn't hit the ground. It blew up in the atmosphere. Now, there may be in pieces, but nobody ever found any pieces from it. The Chelyabinsk meteor did have some pieces found, but, they didn't get to the ground where the actual, that's the approach of the Chelyabinsk meteor, it grazed the atmosphere. So let's get out of that. This gives y'all some references here to these various meteors. Again, Chelyabinsk, Tunguska, Chicxulub. Well, the one we're talking about is way back up here. Let's see. Yeah, it would be right about here on this scale. So going back for those that are just joined, once again, there is a lot of concern you can see here on space weather. Well, actually, over parameter viewer here in JPL, it shows the dot for this meteor, 2004 GJ12 being right on top of us, but that's because we're so far away. And of course, here on the space weather page, it shows it looking like an impact, missed distance being 0. 0 means it hits us. Well, that's not what's believed. Once again, we think it's a lot of people just doing, we think it's going to miss us by 0.05 lunar distances or 11,600 miles. Put that in kilometers, 18,700 kilometers. Size 9.4 feet or 2.9 meters, much smaller than what we think would hit the surface of the Earth or cause any major damage. Basically, it should burn up unless it's one of the rare iron meteors. So once again, I got some notes. I was getting some traffic. People were asking me about this, so I decided to come live and just get this out in a hurry. I wouldn't be concerned about it. Easy, Gregors. Yeah, we're taking it easy, John. I'm just telling people, don't lose no sleep on this because it's small. It's likely to burn up in the upper atmosphere, and it's if it hits Earth, but it's most likely not going to hit Earth. The probability of hitting Earth is small. Again, it's going to miss us by a distance that's greater than the diameter of the Earth. The Earth's diameter is 8,000 miles, and the missed distance is 11,600 miles. But it is coming inside the geosynchronous satellite orbits. And that's where I pay attention. When something starts coming close to the geosynchronous satellite orbits are coming inside, I pay attention to Apophis, April the 3rd, Friday the 13th, April in 2029, we'll make a similar pass. It's going to come inside and it'll miss us by about the same distance. Apophis is much bigger. So one thing we could do is just come in here to the orbital parameter viewer. Cool thing about this small body, look at that. If you know the number of an asteroid, or if you know the, if you can correctly remember how to spell an APH, APH, shit, I can't even spell it. How you spell it? No, I missed it. I was looking at it earlier. Shoot. Anyway, guys. So there we are. We're expecting a miss. I will come back and do more of this stuff later. Anytime we think we got something coming close, or if you guys are getting worried about it, I'll try to come live on these channels and give you guys an update. How to spell Apophis? A-P-H. Apophis. Let's try that. No, that ain't right. Yeah, even spell check don't know the right answer. I have to look it up. I forget. I'm just an engineer. I'm not an English major. We engineers can't spell nothing. That's our weak point in general. I used to have a spelling test. I just couldn't remember it later. Just goes to show rote memory has got its limitations. Oh, we got a busy neighborhood come up. Look at all that stuff. That's all the ones from the chart there. It's going to be a busy month with flybys and so forth. So that's what we're looking at. That's the one that this other chart showed us missing us by a good bit. Again, that one is this one. That was a big one, but it's missed us by a good distance. So nothing here to be worried about. Nothing to lose sleep over. How's everybody doing? Hope you're all doing good. There we go, Bev. Thank you, Bev. I'll go back to that. Just couldn't remember off the top of my head there. Let's see. I can't even type. AP. Where'd it go? AP. OPHIS. Hope that's it. There we go. 2000. I should have remembered the number on that. I used to call it 2004 Minnesota 4. Forgot about that. I could have entered that. There's Apophis. Then we'll see close approach data for Apophis. This gives us years in the past and years going forward, 2022. Let's see. We want to clock this thing forward. We got to get up to our present day. Oh, Lord. They got to go all these passes in the past. All right, let's just keep clocking. Whoop, I went too far. All right, April 13th, 2029. Right here. Minimum distance is unfortunately given astronomical units. In astronomical units, the distance between the Earth and the Sun. It's all in kilometers. Lovely. So it's going to be 0.00025 of an astronomical unit. So if I stick that number into a calculator, multiply it by 0.3025, I'll tell you what the missed distance should be in kilometers. Times 0.00025. So Apophis should miss us by 37,399 kilometers. Now, if I multiply that times 0.6 times 0.62, I believe, that's 23,000 miles. So it's coming in at about the range of our geosynchronous satellites, which is further out than what they originally thought. So Apophis will be about twice, a little better than twice as far away from us, but it's a whole lot bigger body. So if they're off on that, we could be in trouble. But it's going to pass us almost twice as far as this 2024 GJ2, subject of what we came in here for. So there you are, my friends. Unless the astronomical distance is actually put in miles instead of kilometers. I hope they didn't mix units on this. We had a satellite, a lander one time. It was supposed to land on Mars, but they forgot to convert metric to English, and they was using mixed units and developing the thing, and they got off and the thing crashed into Mars. So I imagine this is in kilometers since they just expressed it in kilometers down here. That's what I calculated it for. If I'm off, it's still going to be a good miss. So that's the good news. Once again, Asteroid 2024 GJ2 will pass Earth like this right here. Earth will deflect its orbit a bit. I don't know if that's going to change the outline years of the orbital predictions, and they may have to update it. So here's other close approaches for other asteroids. That most of these are just discovered. That 2024 number means they were found this year. So this gives you some background on that. Now the ones that's coming in within a lunar distance, so 2023, we don't care about that. All right, so this is this is the ones within a lunar distance in 2024. Okay, so we've already passed March. Yeah, so we haven't discovered a lot of them that's coming up. We don't know of anything else coming that close. These smaller ones are usually just discovered like recently, most of them. That's why this pretty much cuts off at this point in time. All right, enough for all that. So that's the story, guys. The good news is two things. One, it's going to miss us by more than the diameter of the Earth, a little bit more, at least we hope. And two, if it don't miss us, it's not big enough to get through the atmosphere or even cause damage on the surface if it should explode in the upper atmosphere. Now, if it's got some real heavy element components, you might get meteors hit the ground. Most likely it's going to go over the ocean or uninhabited ground area. A lot of money wasted on a simple mistake. Trump 45, that's true. Betelgeuse, yeah, Betelgeuse is a star which is the right shoulder star, I believe, of Orion, which is going to go boom, and we just don't know when. Well, we don't know when we're going to see it boom. It's far enough away, it could have already gone boom. It's several light years away, a few hundred light years away. So, boy, I have to look it up. What's Betelgeuse? 300 light years? 300, 600? I have to go look it up. Betelgeuse is a red giant. At one time, it was a really bright star, but it's dimmed. It's changing brightness a lot. So they think it may be about to go boom. So maybe one night you'll be standing out and Betelgeuse will light the sky. Betelgeuse, when it goes, will be bright enough to be seen in the daytime. You'll be able to walk out in the daytime and see a star in the sky from its nova, supernova. It'll be a nova. What's the diameter of Apophis? Oh, holy smoke. I have to go back and look it up again. Something I knew at one time. Let's see, are we still on Apophis here? Yes. La 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 la. I don't know where they put it on here. You just got to go through all this data. Diameter of Apophis is 0.34 kilometers. Bennu is actually bigger, 0.34 kilometers. So it's a third of a kilometer in diameter. It's big enough to cause a lot of damage. Now let's put Bennu in here. I think Bennu's got two ends, I think. B-E-N-N-U. Yeah, I have to. I'm not a spelling major. There it is. I got it right. Bennu. Bennu has a diameter of 0.482 kilometers. It is larger than Apophis. Both of those are big enough to cause a lot of damage. Bennu even more so. Close approach data for Bennu. I hope we're not showing me way back in the year 1900. Yeah, we got to scroll this and forward a few too. Get up to our current date range. But we want to go past. Oh, what happened? We just went to 9. Yeah. 21, 29. I think 2180s is where it's got a chance for impact. Wow, look there. 2135. The minimum distance is 0.13. That's pretty close. 0.13. That's not as close as Apophis is going to get, but this is a bigger asteroid, and that's a long way out. It could change between now and then. So again, if we use the distance here of an astronomical unit in kilometers, I know it's 93 million miles, but you know, miles is still in my head. So to convert this to kilometers, I got to copy and paste it. I just killed the calculator and pull the calculator back up. We'll put it on calculator here. Boing. Come on. All right, didn't copy and paste. Let me do that again. Bear with me 1 minute, please. I'm trying to copy and paste into the calculator. There we go. Got that many kilometers, and the missed distance is 0. See, the other had a missed distance of 3 zeros, 0.25. This is 2 zeros, 0.13, so it's further out. Times 0.0013 equals 194,000 kilometers times 0.6. It's going to miss us. It'll come in between the Earth and the Moon. It's going to miss us by 116,686 miles. It will become Apophis in 2135 will pass between the Earth and the Moon. It actually looks like it's closer to the Earth than the Moon. The Moon must be on the other side of the Earth or something when it passes through. That's minimum distance. It's got a maximum distance too, which is larger. So that tells you there's some error in the calculation, but the error is in the let's see, the tens, hundreds, thousands, the 10,000ths of a decimal range. So that's a fairly small error. But, there are other forces that act on these asteroids, and over, we're talking over 100 years in the future. It could change orbit. There is a small probability that Bennu could hit Earth. Apophis will actually come closer. Oh, I'm not doing share now, am I? I thought I was doing a screen share. I was like, those numbers up. Sorry about that, guys. NASA and the Army got to get their act together and start learning how to blast these threats to everyone's existence. Well, they did the DART experiment. We covered that live on this channel when the DART impactor impacted, that I believe it was Deimos. We had the two asteroids, one orbited the other. It knocked the heck out of it, caused a huge debris cloud. Now they think that the debris from that impact has a high probability of striking Mars. So NASA has attacked Mars. Mars attacks, Earth attacks. Marvin the Martian is not going to be a happy camper, to say the least. So I watch you a lot, but don't always get a chance to comment. Much love to you, Mr. Gray. Well, thank you. So Soil to Soul. Hey, that's a good name. Soil to Soul. There you go. Good morning. Hope you're doing okay. We survived the storms here in South Mississippi. Everything's fair. Well, yeah, they kind of went south of me and some went north. Lost a greenhouse, but I think we can fix it. Yeah, I know what that's like. I lost mine last March of last year. Oh, just after I put a bunch of money into it. All right, I want to go through the chat room here fast and just see what folks are saying. And we're going to call it a night. I don't want to make this a real long video. I just want to bring, oh, what happened? It knocked me out. Let's see, come back here. Bob Nielsen, is that what some call the beer? There is no planet hiding on the other side of the sun that's going to be whipping around and impacting, or no other star, Earth, in any time in the near future. Okay, I see somebody else spelled Apophis for me. A few of you other ones. Yeah, I just wasn't getting it tonight. I don't know why. Sometimes my thinker ain't all turned on. Not in the spelling department anyway. Bob Nelson. Well, no, it's not Nibiru. I did a video on Green Greg's explaining why you didn't got to worry about Nibiru. Just go to my Green Greg's channel and click on videos. When you see the hourglass, type in Nibiru, and you'll see why you don't have to worry about that. I'm not saying there's not a planet way out there in the solar system, unknown planet. They're looking for that, but there's nothing that's coming inside the inner solar system anytime soon. And it's definitely not something hiding on the other side of the sun. The orbital dynamics means if it's on the other side of the sun and it stays on the other side of the sun, it's in Earth's orbit and it won't hit us. You can't be coming in from outside the solar system and always be on the other side of the sun. That's not happening. So don't worry about Nibiru. If you press notifications on another channel, it'll put that first and delete others. Oh, Apophis, is that what the Tesla guy wants, to get 1 million people to Mars by 2030? No, that's not it. But I think he is concerned about the fate of our civilization overall. And I think that's about as soon as he hoped he could do that. He's going to be hard pressed to accomplish that now, because he's only got 6 years to make that happen. But a lot of people are picking 2030 as a date to have certain things in place and blah, blah. Why 2030? Why 2030? What is that all about? Hey, Alice Van Bergen, how you doing? Just got here. It's baby season. I'm busy. Well, that sounds good. Bill asked if the sun would come back. Bill asked if the sun would come back since it went out. Oh, Lord. He knows better. He's messing with you there, Bev. Pretty sure. Got a good chance that Betelgeuse will blow in 1 million years or so. That's right. A good chance in 1 million years or so. I would hope that would happen in our lifetime, just because I'd like to see it. That's rather selfish of me to want to destroy the constellation on Orion. It wouldn't destroy the constellation. There would still be a bright nebula there where Betelgeuse is for a long time to come. You'd be able to see. Eventually, you'd have to have a telescope to see it. But there is a nebula called the Great Nebula. It's the only celestial object like that you can see with your naked eye. I think you can actually see the Andromeda Galaxy, maybe. But the Great Nebula is the center sword star in Orion's sword. It hangs from his belt. Orion's got a belt, and he's got 3 stars that hang down as a sword. The middle star is a nebula. There's a nebula you can see with your naked eye. One of these days, Betelgeuse will be like that. It'll be a star. 2050, what's happening in 2050, Jason? John Baxter, surely there's really intelligent aliens up there. They would be cleaning up space junk. We got lots of space junk, that's for sure. About to get into veterinary school. That sounds good, Alice. Congratulations. Really intelligent aliens would make it duty to protect the planet like ours from space junk. Well, space junk ain't really a threat to the planet, but it may be a threat to our access to space. If you get a chain reaction, run away from so much space debris hitting each other, it start taking out more and more satellites, create more and more debris. It's like a chain reaction to get to the point that you got so much debris up there, we may not be able to have access to space. As we're launching now scads of satellites, that is a risk, especially if there's a space war. That becomes a huge risk. Let's hope we don't have a war where they're actually blowing up satellites in space. 2050 is SpaceX plan for 1 million on Mars. Okay, got it. 2050. Yeah, I think their plan was to try to land somebody by 2030. I don't see how they can do it. I don't think they will put anybody on Mars by 2030. They might by 2040, maybe 2035. But this large rocket they're doing is taking them a lot longer. The Starship project is taking them longer than they thought it would, as big engineering projects tend to do. That's a very complex project. They're doing really well with it so far. Let's wish them luck, and I hope they don't have a pad explosion or something near the pad that might take out Boca Chica or that community just north of it. That's within range of the debris, and that's not a good thing. Hey, Rodney, how you doing? So for those that's just joined, what I just presented, catching on the rewind, the sun will come back tomorrow. Yeah, the sun's coming back. So this asteroid 2024 GJ2 will come in between the Earth and our geosynchronous satellites today. It will miss Earth. It should miss Earth by 11,600 miles. Diameter Earth is 8,000 miles, so it should miss us by slightly more than the diameter of the planet, almost a quarter more. But if it should hit us, it's only 2.9 meters or 9 feet in diameter. The threshold for an asteroid that could cause damage if it explodes in the upper atmosphere, about the size of the Chelyabinsk asteroid, is about 18 meters. To get through the ground, a typical asteroid would need to be about 54 meters across. It'd be a fairly big asteroid. However, it could have meteorites strike the ground in various places. The first person ever got hit by a meteorite was in Alabama. I think late 1950s, one went through the roof of this woman, and it hit a dress or something, and it bounced. She was laying in the bed, and it hit her leg. She was the first documented person hit by a meteorite. Although there's written record, it seemed to indicate that there were quite a few people taken out in China in the historic past some long time ago. I'd have to go look all that data up. I don't remember the specifics on it. But there are stories that there may have been meteorite showers. Meteor showers is just stuff in the atmosphere burning up. Meteorite is what hits the ground. Meteor is the plasma trail that follows a meteoroid. A meteoroid, the typical meteoroid, it makes what we call a meteor, is about the size of a grain of sand. So those things hit Earth all the time. There's a lot of that stuff up there. It hits Earth all the time. And the best almost meteor shower I ever saw was the Lemans. Lots of real bright bolides, one after another, after another, after another. When my mother was young, she said that her and her oldest brother, they're both passed away now, went out in his early 30s, 1930s, and the sky looked like the sky was falling. She said the whole sky was full of these falling stars, and they just marveled at it. They thought the sky was falling. So, you've heard that song, Stars Fell on Alabama. I think that was some earlier meteor shower, though. But my mother got to see that. I would love to see a meteor shower one day. That would be awesome. So how close will it be to the satellites? Could it hit a satellite? Well, it's possible it could. Now, they're still a fair distance apart, so it probably won't. But it will come within the orbit about halfway between Earth and the geosynchronous satellites. The geosynchronous satellites are about 22 to 23,000 miles above the Earth. As a satellite's orbiting the Earth goes around the Earth every 90 minutes. If you're in a low Earth orbit, roughly every 90 minutes. The further the orbit is out, the longer it takes to get around. It's covering more distance because the total circumference of the circle it's covering is bigger. To get a satellite where its orbital period around Earth is exactly 24 hours, the exact same as the rotation Earth, you got to be in geosynchronous, that is synced with the geo Earth. That means that every time the Earth turns, it turns. So if you want to have a satellite stays in one place in space, which is really good for telecommunications, for weather satellites, for these communication sites, where if you want to be able to point up to one place in the sky and then send a signal from it maybe to another satellite and back down the ground, that's what the geosynchronous satellites are for. But the data time for something going all the way out to 23,000 miles, and they link across another satellite and link back down to Earth, you got a lot of distance in there, and it's actually slows down the communication. You got a little bit of a time lag. If you want to make it quicker, you want that stuff real close to Earth. That's why Starlink satellites and a lot of your other constellations are trying to be just high enough that they won't fall back in the atmosphere due to atmospheric drag. There is some atmosphere even at these low Earth orbit satellites orbit. If the sun gets active and our atmosphere expands, they drop out faster. And some of the Starlink satellites, did drop out because the sun was a little more active than they projected. But that's what happens. Oops, sorry about the mistake, Ron. What is that? So it's always possible it could hit a satellite, but it's not very likely. It's highly unlikely. If it did, it could mess one up. But it's going to come inside the orbit of the geosynchronous satellites. Now, geosynchronous satellites tend to orbit in a belt around the Earth. So that, it's just right over the equator, basically. So you got this one point you point to them. Makes it easy to locate them. Those great big satellite dishes people used to put in their yards, they were pointed at geostationary satellites. I think the smaller ones are too. It's just the satellite's bigger. The size of the antenna on the satellite is inversely proportional to the size of the antenna on the ground. If you got a ginormous big enough antenna on a satellite, then you could have something that's almost in your phone on the ground for an antenna. Just to give you an idea. Anyway, Captain Trips, thank you. John B. Can't depend on the aliens being peaceful. They might look at us as fresh meat. That's right, Jesse. They may not be here to serve us unless it's on a platter. Was that old 50s movie where at the end of it, they had a book, how to serve humanity or how to serve man, and in the end it was on a platter. Wise Al, how you doing? Good to see you. Alrighty, guys. So we're going to call it a show. We've been on that for 47 minutes. I covered the pertinent material up front. Thank you for sharing my links, Rodney. And everyone, if you're not subscribed, bang the update notification bell and click all. Bang the bell. And click all for y'all. Alrighty, folks. Thank y'all for watching. Thank you, mods, for what y'all do. And I may be back. No, not tonight. I got a video I'm going to try to record and post on Green Greg's tomorrow, and probably be on Soilhead News again tomorrow night, maybe. I don't know. I'm going to be at a function. I may not be able to come on tomorrow night. It might be Friday night. Unless, to serve man. Exactly, Jason. Unless there's something crazy going on. I mean, we could have a war break out between Iran and Israel, maybe Iran and the United States, any day now, any minute, any hour. This could happen. It could happen. It may have already started 2 minutes ago. And we just haven't got the word yet. I don't know, guys. Let's hope not. But we'll keep our eyes wide open and head on a swivel, as I always tell you guys. They passed funding for a train on the moon. Yeah, well, it's just a study right now, Wise Al. They're funding Northrop Grumman to do that. That would be interesting. But it looks like China's ahead of us, and it's going to be dangerous in terms of what they're spending and trying to do on the moon. Looks like they got an edge. And that could be very dangerous. I plan to do a video on that topic in the not too distant future. I started a PowerPoint presentation on it like over a year ago. Hopefully I can finish it and get it loaded. I want to go back through and recrunch some of the numbers on it. It kind of slowed me down. I just finding time to do all that is rough. Yeah, they won't be able to commercialize it the way we would, but that's another story. Love you, Greg. God bless you. Well, thank you, Alice. Appreciate that, and all of you for being here. So, Wise Al, hope you're doing good up there. Hope you're back in Arkansas. Hope you got to see the eclipse. Somebody sent me some nice pictures of an airplane about to go pass over where the eclipse was. That was pretty sharp. So maybe I'll share that with you guys sometime. Anyway, thank you all for watching. Thank you, mods. And to one and all,